And we should be live. Now, I'm used to actually being live, like as in live streaming, but today we're recording. Welcome, everyone. I'm David Tischler. I'm a developer advocate at balena, and I'm happy to have two guests with me for this session. I'm going to start off down here below me. Katil, would you like to say hello and give a brief introduction?
Yes. Hello, balena world. That was a bad one. Bad start. My name is Ketil. I'm living in Norway, where I usually, in my day job, work as a project manager in a media innovation cluster. A great place to work. Actually get to use a bit of all my skill set in the job. Some development, some project management, and some old-fashioned innovation. So it's great to be joining you guys here today. And I'm also looking forward to talk about my little pet project, which is the balena ADSB project.
Yes, I can't wait to hear about it. And Alan, you want to say, where are you? That way? No, you're over on this side.
Oops.
Yeah. You want to say a quick hello?
Sure. Hi, everyone. I'm Alan. I'm a hardware hacker here at balena, making projects and also using great projects from the community. And I'm also an aviation geek, so I'm really excited about today as well.
Awesome. Well, thank you, guys. That is perfect because that's what we're going to be talking about in this session. We're going to combine a couple of different topics here. Our attendees today are here for a hackathon, and I noticed that there's quite a few folks that are just getting started in the balena ecosystem. And I thought, let's showcase some projects that people have built using the balena tooling that, quite honestly, I think are pretty interesting and pretty neat. So this one here in particular is the ADSB Flight Tracker project, built by Katil and implemented by, by Alan. I don't have this hardware yet. I need to go shopping and make a purchase. But the ADSB Flight Tracker project is all about tracking overhead aircraft. So we're going to show off a little bit of the hardware that's required. We'll talk about how it is built using, I think we'll start by looking at balena Hub, but then go from there over to GitHub and have a quick peek at the repo. And then let's show off some interesting data. Sound good, you guys?
Sounds great.
Oh, I see some nods, so
Yes.
I think we're okay. All right. So first things first, Katil, do you want to give a brief intro to ADSB? I'll bring in my screen share and I'll take a peek at the README kind of as you're talking through it.
Sounds perfect. So ADSB is a radio beacon that most commercial, or rather all commercial aircrafts in our part of the world sends out while in flight. It's a beacon containing information about the aircraft's position, altitude, heading direction, and also speed, and some other interesting parameters. These data are broadcasted on a specific frequency, 1090 megahertz to be specific, and it's a frequency which you can easily you could easily decode the signal using a simple USB-based radio stick, so-called RTL-SDR radio. What makes this interesting? It's several things that makes this interesting to us aviation nerds and air lovers. But one thing is that you get to see the flight traffic going on over your head. that is fascinating in its own right. Just by it's like counting sheeps at the night. If you need to get no, just kidding. It's a lot more fun than that. You get you get to see you can see this long haul flights with a really high altitude and might wonder where this plane is going. You could easily head into your own local dashboard using the solution and see that, wow, this flight is going from Dubai to San Francisco or something really fast stretch, and it's fun to know. But also this can be used, it's something that actually could be used for useful stuff as well. For instance, in journalism, which I'm focusing a bit on in my day job. By also decoding this data, you could, in addition to just have it on your own balena device, you could also feed it to a lot of different third-party services, such as Flight Radar 24, Flight Aware, Plane Finder, Radar Box, Open Sky Network, ADSB Exchange, and the list goes on. And when you do that, these services grant you premium access to their services, which is something that would cost a lot if you were to subscribe for it using Pocket Cash. So basically, if you just want to feel like earning some money on implementing this, you would basically have returned your investment in the first month, because the parts costs about $100, but these services will cost easily hundreds of bucks per month, actually, if you do all of them. So it's a really good investment as well, and also a fun factor, and it's crowdsourced data. We all like to contribute in this community. And also this project obviously is also fully open source on GitHub, so you could also modify it, customize it, and contribute, which is very welcome.
Your PRs are always welcome.
Yeah.
Awesome. Well, thank you very much. Before we get into the nitty-gritty details, I want to just quickly show off what it is that we're sort of talking about here. So let me bring in your screen just so we can take a quick glance, and we can come back to this for a deeper dive in a bit, but I want to give the viewers a little bit of context as to what we're kind of talking about here.
And this, just to say that first, this might seem scary to beginners at least. This is not where we would typically be starting. This is me 5 years into my journey, where I have optimized the receiving end here, also added a bit of services. In here, I also implemented another balena service, namely the basics station LoRaWAN gateway, which you can see on the upper hand left side of the box. It's powered using Power over Ethernet plus with 4 amps of power. And then there is also a secondary dongle, which is my newest project, where I'm implementing support for something called the Open Glider Network, which is on a different frequency, but also gets smaller aircraft like microplanes, gliders, and paragliders. So that's the next step for this project. So it's basically 3 different things running in one, but we can come back to that.
Yeah, we'll come back to it. The reason I wanted to bring this up, though, is to essentially show that what we're talking about, we'll do a little dive into the project there through Balena Hub, and then over in the GitHub Docker file, just take a quick glance at like what's going on. But to give the viewer some context, essentially the end result is we're going to deploy a container onto a Raspberry Pi, or similar type of device. I know it also works on a NUC or a Jetson. But point being that your repo will build a container. The container gets deployed onto the device, and you need this dongle, this radio, the RTL SDR USB dongle to be hooked up. And that is what is capturing the signals from the aircraft. The Pi itself out of the box, the Pi doesn't have that capability. But once you get the dongle attached and get the antenna on, then you can start grabbing that data coming off of the aircraft. So I thought it was, like maybe worthwhile. Let's kind of just show, even though I know you have an advanced setup there, but so, all right. So let's do this. Let me get my screen share back on. I don't know what happened to it, but get that back in here. To get started with the project, the easiest way is going to be through balena Hub. And balena Hub is essentially like an app store for IoT projects. Those of you who are watching this video and participating in the hackathon, as you're building out your projects, your Docker files, and pushing your code and writing your applications, that's wonderful. And you can push it to your local device sitting on your desk right in front of you. You can push it to fleets of devices, no matter where they're located. But you can also add your project to balena Hub. And in balena Hub, you become the fleet owner, and individuals literally around the world can add your application to their device. So in this particular case, I don't know, I haven't checked recently, Katil, do you know how many folks have added? I guess I can go take a look at that at some point.
Yeah, that would be interesting.
Yeah, we'll have to pull up some statistics on this. Normally we would be showing, if it was in the fleets section, we would have some metrics on that. Like, for example, we'll just take the first one, AirPi Play. And this one is by one of our hardware hackers, Rahul. And so you can see he's got 548 devices in his fleet. Now, Katil, I don't know if you've got 549 or more devices in your fleet. We'll find out for you. But the point being is, these are folks literally around the world who have installed and are running, in this particular case, AirPi Play. So it makes it easy, though. You just click the button. Oops, let's come back to deploy. Now, let's take a look back in GitHub. And in here, we can see you're using a Docker Compose file. The Docker Compose file builds, or essentially is the recipe for building all of the containers that are needed to run the software stack. All of this one already
be a bit infamous in size.
Yeah, I was just going to say, this is a large Docker Compose, but that's a good thing. Because for our folks that are getting started, there's a lot here to sort of reverse engineer and dissect and learn from. Having a larger Docker Compose, in this particular case, is good because you're using nearly all of the features. I see you've got environment variables, you have ports, you have depends on, which means that this container by the name of Radar Box depends upon dump 1090, which I think you mentioned was the frequency. So this is actually really good and very valuable, having a nice large Docker Compose to draw from. And then inside of each folder, you have the bits and pieces, the individual containers themselves that are running, that are the service, is what we call that. And so I happen to just choose Plain Finder. Let's take a look at its Docker file. Each folder has a Docker file, and we can just sort of take a look at what it's doing. So it's grabbing from Debian Buster as the base image. It's exposing some ports. You've got some environmental variables getting defined. You're doing a quick apt install. You're copying in some files, and then eventually, chmod to make them executable, and then eventually running the service, in this case, start.sh. And again, you can kind of come back and then take a look at, all right, well, what's in start.sh? It's all here. So attendees can certainly see what is going on. It's all transparent. It's all open source. It's all in GitHub, but it's an extremely valuable learning exercise.
And that's one of the nice things with using both Balena and also its underlying Docker infrastructure, that it's easy to iterate. So it's once you have found your kind of way of structuring the images, it's easy to replicate and expand the service without breaking and risking breaking the setup, because you could always roll back and you have all the versions and iterations on file, so there is no risk of ruining anything. And I have a few of these, quite a few of these receivers running remotely, and that's the beauty, the big beauty of Balena, that you could do everything remotely. Basically plug it into some 4G hotspot and it comes up in the Balena dashboard, and you could update it, configure it, and do everything from remote. And if you break the deploy, you could always run back. And this is magic, guys. Using manual SSH tunnels, and always had to hike into the mountains to kind of reset stuff. It didn't scale. It wasn't viable. And then finding Balena makes that a thing of the past. The best thing maybe is that you have some magic running when it comes to these memory cards. So those don't burn out as fast as they used to. I don't think I've had to change a single Balena-based card after I changed to you guys. Several years now running on this.
Yeah, it certainly can happen. So I'm glad to hear that you have been lucky, but SD cards, they can and do wear out. So yes, we implement a couple of, they're not tricks, but a couple of features to help extend the life, minimizing the write cycles onto the SD cards, by default logging to RAM, etc. But yeah, I have killed a few along the way, so it happens.
We all have. But, it's not that common with the setup. That's,
definitely helps.
Yeah.
So let's take a quick look then. We've kind of covered the architecture, how to deploy it. And we started off, of course, by describing the project. Let's take a look then at a bit of it in action. Now, Alan, you must have climbed up onto your roof prior to us starting this recording, because I know you have some hardware on your desk, but that hardware is not normally on your desk. So what did you go up there and retrieve?
Well, let's start with the part that actually was inside. That's the Pi. Now this is a Balena fin. This is basically a Pi 3, but what we would consider an industrial hardened Pi 3. So this is yeah, exactly. But you would get basically the same operation with a Pi 3. And what we have here, this is like an intermediate setup. This is definitely not like Katil's image that you saw, but it's a little more than a starter image. Let's say it's slightly enhanced, but you notice I have 2 dongles here. So you can do the project with just any, either one of these.
Okay.
And these are just standard type of, it's a type of RTL SDR dongle, but these are optimized for that 1090 frequency. At least one of these is. But I think you could use a standard RTL SDR as well, right? these are like $20 each. Some of
That's
them.
what I was just going to ask. That basic one is about a $20 part. So now I understand that you guys have some pretty advanced setups, especially Katil's that he showed, but you really could get started for the price of the Raspberry Pi. They start at $35. Okay,
Right.
you need an SD card, you need a power supply. Yeah, I get that. But really, it's just the basic dongle would be enough to get going, and that's in the $20 range. Let me actually zoom back in on you real quick, Alan.
Sure.
And so that's the green one you think right there is the basic one? Or is it the blue one?
I think Katil would probably know better. I forget
Yeah,
which
the
one
blue
is.
one is the 1090.
Yeah, this is the
blue one.
1090.
Yeah.
And this is a different one. Maybe we'll let Katil describe what this one is for. But I just wanted to say that, yes, with just a Raspberry Pi and this $20-ish dongle and the antenna that it comes with, you notice I've attached these heavy-duty coaxial cables. This is not necessary either. This is also USB extender, just because these are so large, they can't plug into this side by side.
Port, right? The port, yep.
So really, there's still, even though mine's beginner to intermediate, I have a lot of extra stuff on here.
Gotcha.
But it's really just this and a Pi and the antenna that usually comes with this, which is a little antenna like this that you could just plop on your desk if you're getting started.
So now you keep that inside.
This part stays inside.
Where do those wires lead?
These wires go outside. Now, I did not drill a hole in my wall. These are heavy duty. I think these are 75 ohm wires. So you probably
that's a big hole.
Yeah, you need to make some big holes, and these are low loss wires. These are actually just cable TV wires. But I think that the impedance is enough that it doesn't really make that much difference. But what I did was, I don't know if you can see this device.
Let me get you zoomed back in real quickly, and we should be able.
That's clever.
This is an adapter, a flat cable, coaxial cable adapter, and this will go right under your window. Like, you can close your window onto this. And so I have this wire usually attached like this, and then it goes under the window, so I don't have to drill any holes. And these are this particular one is available at that's Radio Shack.
Amazing.
You get that
Radio
online.
Shack. Wait a minute.
I thought
they went out of business.
They're still around online, apparently. That's where I got this. And I think this is about $10. And so I really need 2 of them, but I'm just using the one. And it probably introduces a slight amount of loss, anytime you're injecting something in the path of your signal. But I haven't noticed it to be too detrimental. I haven't measured it, but it's pretty good. So this goes under the window. And then on the other end, outside, I have this special ADSB homemade antenna. And you can find plans for these online. But what you want to do is create a ground plane with a piece of metal. And then you want to cut, this is the actual antenna. And they give you yep, this is just a little piece of the center of a coaxial cable. This one got bent because I just dropped it on the floor, but you can straighten it out with a piece of pliers. And this is what we would call maybe a barrel connector right here. It comes with the nut, and you just drill a hole in here, and you connect the coaxial cable. It has a a threaded connector on both sides. And then just insert this wire and make sure it's cut to the proper length. All the instructions are available online. And you notice I pulled this piece of metal from an old PC power supply.
Yeah, that's the case of a power supply.
This is a power supply.
You could go to a hardware store and get a little piece of like sheet metal or something. Not a big deal.
It's perfect because I just then mount this on the side of the house. Just put some bolts through here and nail it through.
Yeah.
And so this just sits there. It goes through the window with this, so there's no no drilling of holes if you don't want to. And then just connecting it back up. There's a little adapter here. I don't know if you can see.
I had just taken you off, but let me get you back. There we go.
This is a series of adapters. And again, you're probably introducing a little bit of loss, but it's, from what I've measured, negligible. But you're changing this regular coaxial cable to, I guess this is what, like SMA connector, I think. Yeah.
really impressive and inspiring. And I
Very
think we
neat.
should also not forget to mention that you are running the only dual band setup of this on in the world, at least in a balena context. So you, in addition to the ADSB 1090 megahertz frequency, also pull down the 978 UAT frequency, which is a special new thing going on in the US only currently at select airports. So I think you are the only person who has been able to
The only
validate
person,
this working, and
the only
there might
person
be
in
more
the world
persons wanting to pick this up soon elsewhere in the US. So please get in touch if you would like to replicate Alan's setup here.
Katil, is your contact information? Let me think if it's on the repo, or they could somebody could just open an issue. Would work.
Open an issue. Yeah. There is a link to. We have a thread in the Balena forum for this, where there is a certain amount of activity.
Yep.
So there are. You could reach me through there. We might consider opening a Discord server that's been requested by some. So we'll see about that. But you will just Google my name there, and you will find ways to get hold of me.
Create a post in our forum thread or raise an issue. Yep, I see it right there on the second paragraph of the GitHub repo. Perfect.
We have done our homework, I guess.
Yeah, sure have.
Which is good.
Right from there. So yeah, maybe if anyone from the US, now you did mention only select airports, so this is obviously being slowly introduced. Alan, you're in the Philadelphia area, and that's one of them. Do you know, Katil, off the top of your head, roughly how many airports have it? Is it just the major, just 5, 10 of them, or are we talking maybe 100?
No, I think it's kind of the major domestic airports, so not airfields with this grass landing runway.
Okay,
but it should be in most big cities in the US.
Okay,
now.
so
And,
major metro areas, that could be 20, 30 different that have it. Okay, good.
And I think Alan, you made it on the first attempt, so it took some days to get traffic because only a few aircraft as well have this transponder on board. But you got it to work, and as the first person ever, so congrats on that.
Thank you.
Here's Alan's data right here. So here's a view of what is being captured by that antenna. And Alan, you were mentioning prior to us starting the recording that you're getting a pretty incredible range out of that setup you have. How far away can you actually get data from an aircraft?
Well, according to this, the farthest I'm getting is 200 to 250 miles from my location with this crazy antenna. Is actually, now that's this is my this is the UAT antenna, which I haven't put outside yet. It has a slightly different length. But once I get that outside, I'm hoping to get more UAT. But my regular 1090 antenna is outside right now, and you can see it's very similar to that, and the distance is pretty crazy. I was really surprised.
That's amazing.
Yeah, and I mean, look at these numbers of positions reported every day from my antenna. Wow. They seem high. According to the...
Well, there's a lot of active aircraft over the eastern seaboard of the United States. That corridor is, probably one of the most traveled up and down the East Coast.
It's a very high traffic area.
Yeah.
And you can see that there are days when I do get a good number of UAT positions, but it's still few and far between. And it may be a combination of my antenna being inside for that frequency and just a lack of planes.
You're going to have to get another of those Radio Shack flat cables.
Yeah.
Could you pull up the live map, Alan, just to show how that looks at your place? It would be interesting to see if it's crowded.
Is that on the Where do I go for that?
That is, if you go down, you can pull up the sky over a little bit up.
Oops.
Up a little.
It was
Well,
a link there.
I did have to
little-
disconnect all of
there-
this. So I don't
yeah,
know.
wait a minute. His is turned off. He was
well,
showing it.
Yeah, it's
Yeah,
so it's
okay.
not connected.
Yeah.
I don't know if I'll be able to get that, but if we
No,
look at
sure,
oh,
it's
okay,
disconnected, but
Nah, his
So,
is
in order,
offline for demonstration purposes.
yes, I had to take it in order to
Yes.
actually have it here
There
on
we
my
go.
desk. It's usually kind of mounted over there, unfortunately.
Yeah.
But yeah, there are a lot of aircraft around here, and I'm in a holding area, so I see the aircraft all lining up to land at Philadelphia International, which is only in a straight line distance
Oh.
about 5 miles away. So there's a lot of traffic.
So the holding pad, the circular holding pattern when they're waiting their turn. Gotcha.
Kind of,
But you still, I mean, so you get a lot of data, but obviously each of those is tracked as an individual, unique aircraft. So you're not really. I see what you're saying there. Yeah, a lot of data, but might not always be a lot of planes. But yeah, I mean, the Eastern Seaboard, you've got all those major airports there. You've got DC, you have Baltimore, you have Philadelphia, of course, New York, multiple there. Boston, you probably have traveling up from Florida, from Atlanta, so yeah, you're in a high traffic area.
Yeah, there's a lot of planes at 35,000 feet that I see go by from like DC to Dubai and just over to Europe. A lot of planes are flying way above. So
I could show just so people get a picture of what the data looks like on the screen. I could show mine. It's not as impressive as yours, Alan. So apologies for that in advance. But at least it gives an overview of what this might look like.
Yeah, it's neat to see. Like what you actually get is pretty amazing when you look at the map with all the planes on it. That's really the exciting part.
Yeah, let's see if we can
disappear?
It did disappear. It was there for a split second, and then it went away.
I might have docked the page just a sec.
No problem.
Apologies for that.
No problem
reload
at
it
all.
now and
I see it coming in. Let me grab it and add. Is it this one right here?
That's Alan.
Sorry,
nope, that's Alan. Got the wrong one. Hang on a minute.
Hang on. There you should have something.
Here it comes now. And let's add that. And here we go. Yep. Radar box.
Yeah. So this is one of the services that this balena ADSB setup gives you. So this is the traffic coming in on one of my gateways in the area here. Still, let's see the max. We have some range. We have, we see the figure is not as high as yours, Alan, but still quite some good figures over the last few days. And I can't see the range, but I am located in Bergen on the west coast of Norway, and we can see it going halfway to UK actually. So it's
that's
a couple
pretty good.
100 of miles there as well.
Absolutely.
So the fun thing, you could also geeking out a bit on the aviation part, but on some of these services you could create alerts to get notification when a specific type of aircraft is flying over your area, or if there is some particular incident code that planes transmit, for instance, emergency, or they have technical issues. You could get an early warning about this. So for aviation geeks, this is what
there are
enjoy doing sometimes when we have spare time.
Is alerting already built into the project or not yet? because there are some other sample repos out there that folks have hacked on where
Yes.
using like Twilio or other services for Telegram bots and things like that.
Yes, correct. There are alerting built in as part of the third-party services you feed.
Brilliant.
But there are also people who have created tweet bots when, for instance, dictators' airplanes has been spotted in the area. Somebody might tweet about it. So
dear.
this is a perfect challenge for the hackathon to come up with
Yeah.
something really great examples.
Specific tail numbers or specific IDs. Yes.
I think in Antonov, the AN 225 is what I'm looking for. You know, if that one flies by. Are you familiar with that? The largest
the
plane.
Russian big cargo plane,
Or
right?
Huge cargo plane with 6 engines, and it's
Yep.
the largest plane. That's what I'm waiting for.
You're waiting for him?
Yes.
Okay, get your alert ready. Well, awesome stuff, you guys. Is there anything else that I'm forgetting? I think we may have covered it all. We did brief background on project. We took a look at some sample. We took a look at hardware, the software. What have I forgotten, Katil?
Could just, if we have a few more minutes, I could just show the kind of new setup I have running outside.
Yes.
Just to end on a geeky note here.
Sure.
So
let me pull
just
that.
Share those images again. So just a sec while I find that. And there we go.
All right. Let me bring that back in. Where is it? Here it is. Okay, and I'm going to make it a little larger, and there we go. All right, so this appears to be a rooftop. So are we taking a picture on your roof right here?
So we can try to zoom out a bit if that works.
No need. I was just commenting on, you are definitely, this picture is taken outside on top of something, so yes.
It's on top of the roof.
Yep.
I have a few setups. This is kind of on the house we live in. So similarly to you, Alan, drilling huge holes in the wall was not an option here. So I've been pondering for quite actually several years how to get this without any drilling with power. So the final solution was actually putting up a Ethernet cable from a shed outside the house, which I had no problems drilling a hole in. And then feeding, and that's kind of the weak part that I don't like that much of the setup, but feeding that shed with internet through a power line adapter. But it's actually worked perfectly stable. You get plenty of bandwidth, and then feeding with the power over Ethernet. This is self-contained, and there is no high voltage stuff going on here, so can sleep safe at night, not fearing that anything will start burning. So on this setup now, in addition to the this is a dual configuration, similar to what, or actually a triple config, similar to what Alan have, but instead of taking on the UAT, which we don't have in Norway, I have focused on something called FLARM, which is beacons used by smaller aircraft such as sailplanes, gliders, microplanes, and paragliders, hang gliders. So that's also something going on in the area, so it's good to tune in. I also fly paraglider myself, and that's also partially why I'm eager to do that. What we have here is a third thing, which is a LoRaWAN antenna. And that's, again, one of the beauties of the balena platform, that you could easily combine different services into one device as long as you have enough power to fuel it. So I, in just 30 minutes time, downloaded the basics station repo, combined that into the ADSB one. And then we're able to have a LoRaWAN, the Things network gateway up and running in no time at all.
On the
And
same
it's
Pi?
super,
Yeah, there was only one
on
Pi
the
in
same
there.
thing
Yeah.
here. So I have
That's great.
just to have a look at the details. You have the LoRaWAN receiver or the gateway. That's on the upper left-hand side. I don't know if you can see my cursor, but the left-hand side of the screen.
No, it's on the. We have just the J. Yeah, I can just see the browser URL, but I can't see the cursor. No.
No, okay.
That's okay. That's all right.
But are those the
But
antennas?
you see the image.
Yeah, you can see the image, and I think that is. I think I do see your cursor, but it's in the upper left of the box, inside the box, right?
I see. Yeah. The upper, you see RAC. It says that's the LoRaWAN adapter, and then we have just below that the green board. That's the Power over Ethernet hat, and all this is mounted on a breakout board. So you have a P in the bottom there, which you don't see, a P4.
No. You had, at the beginning of the stream, a close-up shot of the hardware. What we see on the screen right now is the further out one with the rooftop.
Okay.
If you go to that one you had at the beginning, I bet you would be able to take a better look, because I remember seeing that rack wireless card on there.
I see. Oh, sorry. I have a single monitor output, so I didn't realize
that's
you seeing the wrong one.
That's all right.
To share the right window this time.
Let's get.
So I guess there is no live stream without at least one hitch. So
that's nothing. We've done way worse. That's nothing.
So now, hopefully, you will see the right one.
Let's bring that in. Yeah.
So on the upper left-hand side, you see the oops. You see there is some auto cue here. You see the LoRaWAN board, and then below that you have the Power over Ethernet hat, which is stacked on top of the Raspberry Pi 4. And in the bottom of this box, have a breakout board, which lets you actually have 3 hats, I think, in addition to the Pi. I only used 2. And then it's also room for these 2 dongles, which you see in blue and orange, which do the ADSB and the FLOM, the Open Glider Network frequencies. So this is, again, it was easy to set up from a software side at least. The hardware part was the hard part, no pun intended here. Yeah. But also customizing and adding updates up on the roof, it's really a blast without me having to...
Yeah, you don't have to climb up there to deploy.
Down all day, so it's great.
And what were the 2 antennas in the upper left? Were those your LoRa antennas? If in the previous image where you were zoomed out, the circular, are those circular antennas?
That's actually just an anemometer, so a wind gauge. I have also for. If you actually see in the background, there is this mountain, and this is where this paragliding activity is going on. So. For that purpose, also knowing about wind is of interest.
Yeah,
so here we've been able to combine a lot into one setup.
You've got a lot in there, yeah.
And environmental, this one, which is connected to the same box, but see if we have a more wide shot. I don't think we have. But that, this is just 2 meters from the box, and this is the LoRaWAN antenna. Okay. All right. And then there's the small mushroom thing. That's a GPS receiver to get accurate clock time over the air.
Awesome.
But it's just important to emphasize this is where you get after a long while of geeking and see how can this be expanded, and how can we make it even better. But you will start with something which is much more simpler. You'll buy an off-the-shelf Raspberry Pi, preferably 4. Or if you're feeling fancy, go for the balena fin. I have a balena fin which I will mount somewhere else soon, which is awesome. So you could also do that.
Yeah,
But then,
yeah. Well, you've got everything running on that single Pi. You don't even need the fin. You have all your containers, all your services are on that one Pi.
It works well. The fin obviously has its advantages, and I use that as part of the testbed setup.
Yeah, the fin adds the MPCIe slot. It adds the SIM card slot. It adds eMMC as opposed to SD card for storage, and the onboard microcontroller as well, so you can put it to sleep if need be.
Power options too.
Yep. So
it's a great product. So that could also easily go up on the roof for sure.
Oh yeah.
So
mine is.
Further expansion possibilities. Yeah.
All right, you guys. Well, thank you, Katil, for taking the time spend with us today. I definitely appreciate that. And thank you, Alan, as well, for taking yours apart to show it off. So we appreciate that. Anything else, you guys? Otherwise, I think we're good to go ahead and wrap it up.
Yeah, thanks for the invitation to join in virtually and time shifted on the hackathon. It will be fun to see what projects comes up, and obviously any involvement with this balena ADSB project is encouraged and appreciated. And don't hesitate to involve yourself, submit pull requests and modifications, and let's make this a great project going forward.
All right.
That's my hope.
All right. Well, thank you very much, Katil. Thank you very much, Alan. You heard it from Katil. Any PRs, any issues, just let him know. Get them in, folks. All right. Have a good one, everybody. Thanks, guys.
See you. Thank you.
Yep. Bye.